that actually surprised me last year, and then I have an experience. And the reason I wanted to go next is I spent last year doing action research in my classroom that came out, something that Carl sent out via ChemWest, specifically looking at that modeling and computational modeling and molecular simulation. So those are kind of the two things. I guess I'll start with the demo. So I do have a write-up for this if you've never seen elephant toothpaste or genie in a bottle, or if you're a new teacher, I have a handout if you want one, but I'm assuming everybody's seen that. So last year, at some point, I think I was here a little too late or a little too early, and I was looking at that demo, and I don't really know why, because I've done it many, many times for a long time, and I came across the fact that you can do it in a 2-liter plastic bottle. And I was like, no way! Why are you going to do it in a 2-liter bottle? It's really hot. It's going to generate a lot of heat, and how's that going to work? And I can't actually find where I looked that up, so I don't have where I found it. I don't know what I was doing here late at night or whatever, so it's just the genie in a bottle. So I have about 50 milliliters of 30% hydrogen peroxide, and then I'm going to add some of the manganese dioxide. And so I do this demonstration at the beginning of the year with elephant toothpaste, where it gets all foamy. You add some soap, you decompose it. And I've done it at Halloween, and I've had students use different percentages, and I think I was at about kinetics or maybe thermo, I don't really remember. And the neat thing about this is that kids can see, right? I try to usually get a cleaner bottle, but it's transparent, and this is just an ordinary 2-liter, and the ring is actually really important just for safety so that it doesn't fall over. So I'll put this in. So there's my 30% hydrogen peroxide. And then I'll just put in some, I think the write-up I have says 5 grams maybe. I don't really know. And I'll see if I can get that all in there at once. And so we've all seen this many, many times. But the coolest thing that I did not know is look at the bottle.
Oh,
So the bottle shrinks. Yeah. So to me, I was like, whoa, no way. It's a really great way to show that it's an exothermic reaction. I ended up talking about polymers a little bit, but it was remarkable to me that, again, it's exothermic enough to actually shrink the bottle. And I really like focusing on this reaction and then also water, turning into steam, because a couple years ago, there was a question on an AP exam about asking AP students the difference between this reaction and what happens when water boils. And that was, I think, maybe one of the things that sparked this whole conceptual idea, because students, even at an AP level, did not realize they still will draw water boiling, and they'll break it into H2 and O2. Even though you've talked about phase changes, if you don't have them write those equations, it's just an interesting thing. A lot of them will still, when you say water boiling, they'll write H2 and O2. Maybe because you call it a reaction, I don't really know. But this was really, just kind of remarkable to me that it generated enough heat to visibly shrink the bottle. And again, just for safety, go with the ring stand, just so it doesn't fall over. So yeah, so that's it. That's my demo.